basic version of the carbon cycle because it's going to be the carbon cycle that connects to the oysters. Right? Right. Okay. So what do we got? We got CO2. Where? CO2 where, y'all? In the air. In the air, right? And the CO2 goes where? Into plants. That's a weird looking tree. Okay. It also goes to, what's this? Water plants. I'm just going to say seaweed because that covers them all. Right? All right. Where else does the carbon dioxide go? No, where does it go?
Into the air.
It is in the air. Can I just remind you about this whole thing we've been talking about, the oysters? Where does it go?
The water.
The water, right? Right? And when it's in the ocean, what happens to it?
It becomes C2H03.
Acid, right? Which has this bad effect on oysters that we all know about. Sound good? Sound good?
Yes.
All right. Now, the other thing is that you guys just kind of mentioned here, where does the CO2 come from?
It comes from factories, cars.
Comes from factories, cars.
Animals.
Can we just be like life and also emissions? Is that cover it all? Right? Where do we get these from, by the way? From burning stuff. Where do we get coal from? Dead dinosaurs, the ground, right? Right? Fossil fuels in the ground. Or, what do y'all like to toast your marshmallows over?
Chicken.
What are those made out of? Basically the same thing here, right? By the way, how's coal get made? Mostly plant material, but yes, dinosaurs also. And it gets put down in the ground. Lots and lots and lots of time passes and squeezes it all together real tight. Right? Some chemical reactions involved there too, but that's the short version. Right? So, if this is the carbon cycle, what does this have to do with oysters? How are we going to use the carbon cycle to help the oysters? If this is the problem for the oysters, don't you think we can probably use it to fix the oyster problem too?
Yeah.
Yeah. So what do we have to do to fix it for the oysters? What do we have to do? We have to reduce what?
Carbon.
The carbon. What do you mean by carbon? I think you mean, is this what you mean right here?
Yeah.
Because here's the thing, you guys. Has there been carbon around in the earth for forever and ever?
Oh, yeah.
That's not something new. I'll scoot it back up in a second, Connor. The carbon by itself, like the element carbon, being around is not a new thing, right? Sam, you with us?
Mm-hmm.
But the carbon being in the form of carbon dioxide is a newer thing, right? Is that what you saw in your data?
Yes.
That it's increased a lot very recently, right? Whereas in the past years, we've had more of our carbon right here, right? In the ground, right? But now we're getting more of our carbon out into the air here, and that's what's causing the change, right? Does this sound familiar to you? Okay? So we have to reduce the carbon dioxide. And how do we do that? What are some ways we could do that?
Stop burning coal.
Burn less fossil fuels, right?
We could all get Teslas.
Ooh, there you go.
No. My mom has an electric car. That's not. It's just a stats.
Yeah, so we could, that would, all of those things would allow us, hey, guys, is this complicated? Like when we say burn less fossil fuels, is that complicated? Yeah, it's really complicated. But like as a broad overview of a way to solve the problem, is it? Yeah. So we could burn less fossil fuels. What else could we do? Use other ways, which all of those things would allow us to burn less fossil fuels, right? Do you guys ever hear see the meme about how did Thomas Edison invent the light bulb? By the light of a candle, right? So the fact that we're burning fossil fuels right now as we work on figuring out those other problems, like that's okay. We need to do less of it, right? But that's what we're working on. So what is another solution? As other than just using less fossil fuels because we're using other things, what else could we do to reduce the CO2 in the air? How do we do that?
Stop breathing.
That would probably not be a good idea.
But it would help.
More plants.
More plants.
Less cutting down of trees.
More plants to remove the CO2, right? From the air. Anything else? Any other ideas? What if is it hard to convince people to stop burning less fossil fuels? That's hard to do. What if there was another way to get the carbon dioxide to be less in the air?
Save electricity. Plant more trees.
Well, we did plant more trees.
Don't let it get to the atmosphere.
Yeah, but by that we still have to burn less, wouldn't we? Or are you thinking something else?
No, they don't have smokestacks. They could go to something where it can be
Oh,
used.
like harness your smoke and do something with it.
Yeah.
So,
I mean, that doesn't work for like cars.
like this, right? Make less CO2. Like put it somewhere else, in other words. Instead of CO2, maybe we could turn it into something else. Does that work? Or could we build a filter that would take the CO2 out of the air? It seems really difficult, but would it be possible in theory at least? Yeah.
You just take the carbon out.
Maybe take the carbon off and just leave the oxygen. Something, right? All right. So, all right, give me one idea. Who's got an idea? Shelby, give me one.
Something that's a base.
Something that's a base.
Like I put baking soda with the base. Because once we added the
A base like baking soda.
Yeah, like baking soda. And then
What do you think? What do you think the baking soda might have done?
I said that when if you poured the vinegar into the glue, it would turn yellow. But then once we dumped the baking soda back into the blue, back into the yellow, when it turned yellow, it turned back to blue. So I think it was a base.
So what's your evidence there? Do you think that maybe like the baking soda could have gotten into there?
Well, yeah, but I think when we poured it in, remember when we poured
Right.
it
Oh,
in?
right. Because it poured back and forth.
Yeah.
When poured back in,
I got one.
it goes blue. Okay. What you got, Colton?
Oxygen got in there.
Oxygen. What do you think the oxygen did when it got in?
Like, brought it back to normal.
You brought what back to normal?
The water.
Like, cause we had H2CO3. Like that's the thing that made it turn yellow, right?
Yes.
So what do you think oxygen could have done to that?
And then,
Like it undid the thing? Okay. Say that again when we get back to lunch.
gets in, and it's instead of HCO,
Off my down.
it's H2O CO2.
Wait. So do that again. H what?
So at the start, it's H2CO3, H2O and then CO3.
Oh, like H2O plus what?
The CO3.
Oh.
Yeah.
Wait. Right here you got 5 oxygens, and over here you only got 4.
Yeah. What?
Right?
No, you add H2O. It's like you just add it. Like,
Did I do it right?
there's no plus 2 oxygens.
Well, this is the formula for oxygen that's in the air.
Oh, really?
Yeah.
I have no idea.
Well, maybe if we had like 2 of something, it would be okay.
Yeah.
Like we could maybe work that out.
Yeah.
It's a good idea at least, right?
Yeah.
So there we go. All right. So maybe oxygen got in and like
Just even it out.
basically undid the reaction, right?
Yeah, basically.
Okay. So undid the reaction. And then this, of course, is a question mark exactly how that works, but it's a good idea.
Yeah.
Okay? And how, Colton, what's your evidence for why that could possibly be true? Y'all with us here? Okay. What's your evidence for why this could possibly be what happened?
Because it went back to blue.
It went back to blue, but we know that. But like, what else? Well, how do you think that oxygen? Like, how did oxygen get in?
The hole where you put the.
So it wasn't sealed, right?
Yeah.
So there we go. That's good. All right. What else? Who else got an idea here? What other ideas do we have? I know y'all were writing stuff here before we went to lunch. What'd you got? Look at what you wrote on your paper. If you're looking at your phone right now, that means you're not learning right now. And the people who learn are the people who get the good grades. The people who do are the people who learn. What you got, Thor?
Well, I didn't really have any evidence, but I thought that the H2CO3, it breaks down into H2 plus 2 and CO3 minus 2, right?
Yeah.
I thought that the H2 plus 2 mixed with the BTB to make it blue again.
Oh, so like they reacted with the BTB.
Yeah.
So we could just say H2CO3 reacted with BTB. But we don't really know why. But it's a possibility. Okay. Any other ideas here? Can I like remind you of something? The thing's not sealed shut. Colton thinks that's maybe a result, like allowed oxygen to get in. Maybe. What's another possibility? If oxygen got in, then maybe some carbon dioxide escaped, right? That would be an idea. And once again, the evidence would be that it wasn't sealed, right? Okay. That's a pretty good list of things. Got any more? Look at what you wrote down and see if it's different than what we've got up here already. Which one did you put?
I put CO2 evaporated out, which is like
Same thing, yeah. All right. Well, that's a pretty good list there. So the question here, though, is this would be like evidence that we have that this could be, right? What would we have to know in order to be actually sure that this stuff was true? Like, here's 4 ideas. How could we go about figuring out which one of these things could be true? What would we have to see or know? And we'd have to test it, right? Are we ever going to know what the chemicals did here? Like, do we have a way to test that? Or that the base got in there? Would it help if we could see the molecules? Would that help? Can we see molecules?
Not really.
No. Is there any way that we could imagine seeing molecules?
We can draw.
We could draw them. What? What if we had like a kind of a simulator so we could actually see molecules? Would that help us? Sorry. Yeah. Would it help us if we had some kind of a simulator? Yeah. Should we try it?
Yeah.
Let's try it. Get your Chromebooks out.
Simulator?
I got you a simulator.